Hello, my name is Soali from the Stein Monogastric Nutrition Laboratory at the University of Illinois. I will be discussing comparative digestibility and retention of calcium and phosphorus by gestating sows and growing pigs today. Here is the outline of the presentation. First of all, I'm going to introduce some background and the objectives, and will provide materials and method, state the result of digestibility and retention of calcium and phosphorus, and draw conclusions. Let's start with introduction of this experiment. Nutrient digestibility has been shown to be affected by physiological state of pigs. As an example, this graph shows the digestibility of gross energy, neutral detergent fiber, and crude protein are greater in gestating sows, represented by orange bars, than in growing pigs, represented in blue bars. When evaluating calcium and phosphorus availability, standard total tract digestibility (STTD) values are preferably used because the STTD values are believed to be additive in mixed diets. The reason for this additivity is that basal endogenous loss is considered when the STTD values are calculated. The values for STTD of phosphorus and calcium in feed ingredients are available in NRC 2012 and a paper by Stein and his colleague 2016, respectively. However, most of the values were obtained from growing pigs, and these values were also used in sows' practical application. Therefore, question remains if the STTD values for calcium and phosphorus are also applied to diet for sows. It is well demonstrated that minerals that are positively charged tend to chelate to phytate when phytate becomes negatively charged. A dietary phytate then may affect not only digestibility of phosphorus, but also digestibility of calcium and other cations. Therefore, the objective of this experiment was to test the hypothesis that no differences between gestating sows and growing pigs exist for standard total tract digestibility and retention of calcium and phosphorus, and for the responses to dietary phytate. Moving on to the materials and methods. We utilized multi-barrel sows in mid-gestation and growing barrels. Initial body weight was about 250 and 20 kg, respectively, for the gestating sows and growing pigs. The gestating sows and growing pigs were fed the same diet, but daily feed amount was 1.5 and 3 times maintenance requirement for energy, respectively, for gestating sows and growing pigs, that are close to what they usually are fed. After 4-day adaptation, total fecal and urine samples were collected for 4 days using marker-to-marker procedure. Therefore, a period consisted more than 8 days. 2 experimental diets were formulated based on corn and soybean meal. To create the high phytate diet, 40% full-fat rice bran was included. We also utilized inorganic sources such as dicalcium phosphate and limestone to adjust the level of calcium and phosphorus in the diet. More dicalcium phosphate was used in low phytate diet than in high phytate diet, due to the high concentration of phosphorus in the rice bran. Analyzed phytate-bound phosphorus to total phosphorus ratio was 46 and 76% for low and high phytate diets, respectively. With similar calcium concentration in 2 diets, the high phytate diet contained more phosphorus. The calcium to calculated STTD phosphorus ratio was similar between 2 diets, and these values were also close to NRC recommendation value. 2 additional diets were formulated to measure the basal endogenous losses of calcium and phosphorus. Calcium-free diet was formulated based on corn and potato protein concentrate, and phosphorus-free diet contained cornstarch and gelatin. To calculate STTD values, we first calculated apparent total tract digestibility, then corrected with the values of basal endogenous losses of calcium and phosphorus. Using fecal and urine excretions, We also calculated the retention of calcium and phosphorus. Data were analyzed using procedure mix of ASAS. The model included phytate, physiological state, and the interaction between two factors as a fixed effect. If an interaction in any response criteria was found, the means were separated using a p-difference option. To compare the basal endogenous losses of calcium and phosphorus by gestating sows and growing pigs, unpaired t-test was used. Let's move into the result. The basal endogenous loss of calcium that was obtained from growing pigs was 0.43 gram per kilogram dry matter intake, and this value was close to the values that were reported previously. Gestating sows had about 3 to 4 times greater basal endogenous loss of calcium compared with growing pigs. Unlike growing pigs, there were no data reported previously. Before we look at the data for STTD of calcium, let me set up the first slide for the couple of next slides. In the bottom, different physiological states that were gestating sows and growing pigs were represented and were divided into low or high phytate levels within each physiological state. Lastly, orange bars represent low phytate and blue bars represent high phytate diets. Interaction between phytate level and physiological state was observed that phytate level did not affect the STTD of calcium by gestating sows, but the STTD of calcium was greater if growing pigs were fed the low phytate diet than if they were fed the high phytate diet. Same was observed in the retention of calcium that phytate level did not affect calcium retention by gestating sows, but the calcium retention was greater if growing pigs were fed the low phytate diet than if they were fed the high phytate diet. Regardless of phytate level, gestating sows had reduced digestibility and retention of calcium compared with growing pigs, and the STTD and retention of calcium by gestating sows seemed not to be affected by phytate level. The basal endogenous loss of phosphorus that was obtained from growing pigs was 0.16 gram per kilogram dry matter intake. This value was close to the values that were reported previously and a value 0.19 that was summarized by NRC 2012. Similar with the basal endogenous loss of calcium, gestating sows had about 5 times greater basal endogenous loss of phosphorus compared with growing pigs. Unlike growing pigs, there were not many data reported previously. There was an interaction between phytate level and physiological state that the STTD of phosphorus was greater if pigs were fed the low phytate diet rather than the high phytate diet. But the difference was greater if growing pigs rather than gestating sows were fed. Gestating sows had reduced STTD of phosphorus compared with growing pigs, and growing pigs are likely more affected by phytate level. Basically, similar story was observed for the retention of phosphorus. Phosphorus retention by growing pigs fed the low phytate diet was greater than if they were fed the high phytate diet, but the phosphorus retention rate by gestating sows was not affected by phytate level. Regardless of dietary treatment, gestating sows had reduced retention of phosphorus compared with growing pigs, and the values were almost zero. Let me draw some conclusions. The results from this study tell us that basal endogenous losses of calcium and phosphorus that were obtained from sows in mid-gestation were greater than the values from growing pigs. In spite of greater basal endogenous losses of calcium and phosphorus, gestating sows still had lower values for STTD and retention of calcium and phosphorus compared with growing pigs. Interactions between physiological state and phytate level for the STTD of calcium and phosphorus retention were observed, and these results indicate that growing pigs are more likely to be affected by dietary phytate than gestating sows. The take-home messages of this presentation are that it is not accurate if growing pigs' STTD values for calcium and phosphorus are used for sows, and that the effects of phytate level differ between gestating sows and growing pigs. Thank you for your attention. If you'd like to know more about this topic or want to learn more about swine nutrition, you can visit our website at nutrition.nsi.illinois.edu or search Stein and Pig on Google. I would like to thank AB Vista for financial support.